On September 19th, 2025, something unprecedented struck our solar system. A massive blast from the Sun, a coronal mass ejection, slammed directly into 3I/Atlas, the third interstellar object ever recorded. NASA's top scientists are stunned because instead of being torn apart, Atlas erupted with sudden energy, its tail brightening and stretching far beyond anything Voyager or modern astronomy has witnessed. This wasn't supposed to happen. Now, with Atlas surging as it races toward a close encounter with Mars, every expert from NASA to Harvard is asking, did the Sun just supercharge a primordial object from another galaxy? And more urgently, what does it mean for the future of Mars and the mystery at the heart of 3I/Atlas? A coronal mass ejection is not just a solar flare. It's a colossal eruption of plasma and tangled magnetic fields hurled out from the Sun's corona at speeds that can exceed 2 million kilometers per hour. On Earth, these events are notorious for disrupting satellites, knocking out power grids and painting the night sky with auroras. For spacecraft and astronauts, the threat is measured in sieverts of radiation and hours of lost communication. But in September 2025, the stakes moved beyond our planet. On September 19th, the CME's path intersected perfectly with the trajectory of 3I/Atlas, an object that had already rewritten the rules by entering the solar system from deep interstellar space. The odds of a direct collision at this scale and timing are almost incalculable. NASA's Heliophysics division, led by Dr. Holly Gilbert, tracked the event in real time, drawing on data from SOHO, Stereo-A, and the Parker Solar Probe. The plasma front, dense with charged particles and magnetic turbulence, slammed into Atlas's coma, compressing it with a force no comet from our own system has ever endured under such scrutiny. Voyager's archives catalogue decades of solar storms, but none show a CME striking an interstellar visitor. The physics at play are both familiar and alien. The shockwave drives up plasma density by an order of magnitude, magnetic fields twist and spike, and the coma should, in theory, erupt, fragment, or even disconnect its tail entirely. Laboratory plasma experiments have simulated similar impacts, revealing moments of tail severing and magnetic reconnection, but never with a body this massive or this chemically exotic. Dr. Gilbert described the radio echo from Atlas as the loudest she's ever seen from a comet, forcing NASA teams to recalibrate every prediction model in real time. In the hours after impact, every instrument from JWST to ground-based arrays was trained on Atlas, waiting to see if the object would survive, shatter, or reveal something entirely new about the physics of the solar system. Within hours, the first numbers trickled in from the James Webb Space Telescope and ground-based arrays. Atlas's brightness didn't just spike, it soared. Photometric analysis logged a 2.1 magnitude surge, a leap far beyond standard comet outbursts. The coma, once diffuse, ballooned outward, expanding by hundreds of thousands of kilometers in less than half a day. Models built on decades of solar system comets failed to account for the rate or scale of this transformation. Instead of fading or fragmenting, Atlas pulsed with periodic flares in the ultraviolet and X-ray bands. Each pulse followed the CME's magnetic rhythm, as if the object were responding to the solar storm, not succumbing to it. Astrophysicists traded encrypted messages and hastily written blog posts. Dr. Jian Yang Li noted, "It's almost as if Atlas is thriving on the CME's energy surge." In mainstream circles, the debate circled around exotic chemistry. Perhaps interstellar ices, unknown to solar system science, were releasing energy in ways never seen before. But not everyone was satisfied with natural explanations. Avi Loeb, chair of Harvard's astronomy department, published a late-night essay. Now, these observations challenge our models. Are we seeing new physics or signs of something artificial at work? For Loeb, the memory of Oumuamua's unexplained acceleration lingered. He invoked Sherlock Holmes. If we rule out the impossible, then whatever remains, no matter how improbable, must be considered. On a cable news panel, Michio Kaku speculated, Atlas's reaction to the CME borders on what you'd expect from a powered object, not a comet. The suggestion hung in the air. Was this an interstellar relic with properties beyond ice and dust, or was something stranger unfolding? Data from the next few nights offered no comfort. Atlas's tail stretched and brightened, outpacing every prediction, while the coma's energy output kept climbing. Each new observation deepened the mystery, pushing astronomers to reconsider what they thought they knew about visitors from beyond the solar system. Mars mission control rooms snap into action as soon as the CME, Atlas impact data lands. In Pasadena, the Perseverance operations team pivots from routine soil analysis to emergency readiness drills. Across the Atlantic, the MAVEN Orbiter's atmospheric science group at NASA Goddard flags a spike in ionospheric forecasts, running scenario after scenario through their plasma models. Harvard's atmospheric analysts, led by Dr. Priya Nair, are tasked with running rapid simulations, none of which have ever included a CME-energized interstellar object. Every model parameter is up for debate. Standard protocols for solar storms rely on well-documented Martian responses, compressed ionosphere, brief radio blackouts, and a flicker of auroras at the poles. But the data pouring in from the James Webb Space Telescope and ground-based arrays shows that Atlas's tail is now loaded with charged particles and exotic gases, its coma expanding faster than any solar system comet on record. The risk matrix grows by the hour. If even a fraction of Atlas's energized tail sweeps across Mars, mission planners worry about a chain of unpredictable effects. MAVEN's space weather dashboard predicts a transient spike in high-energy ions. The Perseverance team rehearses uplink delays and contingency commands for the rover's next surface cycle. Atmospheric chemists debate whether a sudden influx of carbon dioxide-rich dust and trace metals could trigger short-lived chemical reactions in the thin Martian air, reactions that might scramble sensor readings or degrade sensitive components. No published model covers this scenario. The closest historical analogue, Comet Siding Spring's 2014 flyby, produced only a brief ionospheric charge and a handful of atmospheric oddities. But Siding Spring was neither interstellar nor energized by a solar storm. Now, with Atlas's trajectory set for a close pass, every control room faces the same question. How do you prepare for a cosmic event that defies simulation? For now, Mars is on alert, and every anomaly, no matter how small, gets flagged, logged, and relayed back to Earth for review. The countdown to closest approach begins. October 2025 draws every telescope and deep space antenna to a single point. 3 I/Atlas will sweep past Mars at just 1.67 million miles, less than 7 times the distance from Earth to the Moon. No probe, no rover, no planetary defense simulation has ever tracked a hyperbolic object this massive, this energized on such a near-miss trajectory. Data from Voyager's archives, recalibrated overnight by teams at JPL and ESA's ESOC, provide only the roughest guide. The models drift with every new input from the James Webb Space Telescope and Mars orbiters, as Atlas's activity continues to defy prediction. Neil deGrasse Tyson, on a late-night news segment, puts it plainly: "We've never before watched an object from outside the solar system get struck by our sun in real time. The universe is showing us it still has secrets." His words echo through control rooms from Pasadena to Beijing, where international coordination calls run around the clock. NASA, ESA, CNSA, and private contractors scramble for observation windows, each nation angling for a front-row seat to the flyby. Bidding wars erupt over antenna time. Encrypted diplomatic cables warn of data embargoes if exclusive signals are captured during the event. Every new observation is a potential game-changer. A sudden spike in X-ray emissions triggers emergency recalibration at the Chandra Observatory. The Mars Reconnaissance Orbiter's imaging schedule is rewritten twice in a single night. On the ground, teams pass terabytes of raw telemetry, searching for any sign that Atlas's energized tail might interact with the Martian atmosphere. Yet, for all the analysis, the fundamental questions remain unanswered. Why did Atlas grow stronger after the CME? Is it absorbing energy, or is something stranger at work? The world waits, suspended between anticipation and uncertainty, as the flyby approaches with no guarantees and no script. On September 19, 2025, a coronal mass ejection struck 3I/Atlas as it travelled on a hyperbolic path through the solar system, marking the first recorded collision between a CME and an interstellar object. NASA's official tracking confirmed a rapid expansion of the comet's coma and tail, with spectroscopic data showing unusually high levels of carbon dioxide. Despite decades of comet research, experts like Dr. Holly Gilbert and Michio Kaku noted that Voyager's archives contain no comparable event. Yet, the cause of the comet's unexpected brightening and energy retention remains unaccounted for in current scientific models. With 3.I/Atlas set to pass Mars at 1.67 million miles in October 2025, mission teams continue to monitor for potential atmospheric and operational impacts on the red planet. For now, the true consequences of this solar encounter are unknown, reminding us that even with advanced technology and international collaboration, the universe still holds events beyond our complete understanding.